Welcome to EDU World Space.
Here we're going to explore the question, why did the Ptolemaic model last for so long? And there's probably a number of good reasons, but we'll just take a look at three. The first one is historically, of course, humans are on the Earth, but historically, humans have had a geocentric model way before Ptolemy came along. And this geocentric model basically concentrated um, on the motion of the sun about the Earth, both the daily and the um, yearly motion of the sun, could be very easily modeled with circle of the sun around the Earth. Uh, so there was sort of a historical reason. Likewise, the lunar motion. And people had time based on those two motions. The second reason is sort of tied into the first, and this is that most orbits of large bodies, okay, we're not talking small asteroids or comets, but the large bodies that are easily observed over and over again, are nearly circular, including the orbit of the Earth. Of course, one of the problematic bodies that caused Newton to really investigate what's going on mathematically was Halley's Comet, which is very non-circular. And the question is, why is it non-circular when everything else seems to be rather circular, at least? Here we're talking about the orbit of the Earth around the sun, the orbit of the moon around the Earth, the orbit of most of the planets around the sun are fairly circular. Whatever small perturbations there were, for example, Mars and Mercury are the most elliptical orbits, but those can be dealt with by small minor corrections to a geocentric model with circles. And I guess added into the history of things is there were, of course, mathematicians who believed in the perfection of circles. So you're kind of stuck with this idea that you got to stick with circles. Um, and the third idea is the idea that you cannot easily measure the motion of the Earth, neither its daily rotation nor its yearly path about the sun. So there were very good arguments that said if the Earth were moving around the sun, for example, or moving in space, then why do stars seem fixed on the celestial sphere? Why don't they move around if the Earth is moving around? Just like your scenery moves around when you're in a moving car. And of course, we now know that the the stars are so distant that you can't measure stellar parallax without careful tools. So you need telescopes, imaging devices, etc., to measure stellar parallax. And of course, that was the kicker that finally did away with the geocentric model. Is, first of all, you had Galileo looking at the phases of Venus as it orbited the sun, and that was pretty much proof positive that Venus was moving around the sun. Now, you still had some holdouts saying, well, that doesn't really prove the Earth is moving. But certainly several hundred years later, when stellar parallax was measured, when stellar parallax was measured, that certainly did end the geocentric model.